Okay, this is the 6-4, 6-6, 6-7 notes. The main thing is in triangles, sides are in proportion to the angles that they're across from. So the side that's across from the smallest angle in a triangle is going to be the shortest side. The side that's across from the biggest side in a triangle is going to be the longest side. So for number one, 70 and 40 adds up to 110. That leaves 70 degrees for angle C. Since A is 70 and C is 70, CB segment and AB segment are both the same length. And the AC segment is going to be the shortest length. In number two, all these angles are 60 degrees, which means that all the sides opposite those equal angles are going to be equal to each other. So segment FD is congruent to segment DE is congruent to segment EF. So we can conclude from this that the shortest side is always opposite the smallest angle. The middle size side is always opposite the middle size angle. And the longest side is always opposite the largest angle. So in a scalene triangle, we've mentioned this before as vocabulary, has all sides different lengths. So none of the sides are congruent to each other for a scalene triangle. The longest side is always opposite the largest angle. Middle side, opposite the middle angle. And smallest side in a triangle is always opposite the smallest angle of that triangle. So we'll label these diagrams to match these. So biggest angle, opposite side's biggest, middle size angle, opposite side's the middle length, and the smallest angle there at the top, and the side opposite that is going to be the smallest side of the triangle. So let's look at a couple of examples. When I name the sides from shortest to largest, so we need to find what each of those angle measures are. 68 and 54 adds up to 122. So that's going to leave 58 degrees left for the measure of angle A. So A is 58, C is 54, and B is 68. Shortest side is going to be opposite the 54. That's going to be AB segment. The middle size angle is 58, so side BC is going to be the middle size segment because that's opposite that angle. And then the biggest angle in the triangle is angle B at 68, which means that side AC is going to be the longest side of the triangle. So we have BA, BC, and AC in order from shortest to greatest based on the angle measures. Same thing for here. For next one, we need to find out what angle N is. So that's going to be a 30-degree angle, so which is the smallest angle. So the smallest side is going to be MO. The next size angle up is angle M at 42. So the side opposite that is side NO. That's going to be the middle size side. And the longest side is opposite the 108. That's going to be segment MN. Here we're doing side lengths, so we're going backwards with this. So the angle opposite the shortest side is going to be the smallest angle. The angle opposite the longest side is going to be the biggest angle. So we've got a 15, a 16, and an 18. So the angle opposite the 15 is the smallest angle. The angle opposite the 16 is the middle size angle. That's angle G. Oh, we're going from smallest to largest. Oh, largest to smallest. So we've got L, E, and F in order from large to small. Same thing with number 4. The biggest side is JL. So angle K is the largest angle. The smallest side is KL, which gives us angle J as the smallest angle, with L being the middle size angle. Looking at number 5, we need to figure out what side WX length is. So we use Pythagorean theorem. A squared plus B squared is equal to C squared. And 11 squared and 10 squared comes out to be 221. And the square root of 221 is a little bit less than 15 because 15 squared is 225. So just, like 14.9 something. So we've got 11, 10, and 14.9. Y is going to be the biggest angle. because that's opposite the 14.9 side. X is opposite the 11 side. That's going to be the middle size length. And 10 is the smallest side. So angle W is going to be the smallest angle. So we're going from, I think, large to small. So we got angle Y is the largest, angle X is the middle, and angle W is the smallest. Same thing with this. Now, if we take an X out of each one of these, we've got a basic ratio of 1, 4, and 3. So the angle opposite the 1 is going to be the smallest angle, that's Q. The angle opposite the longest side, QR, is going to be angle P. That's the biggest angle. Here, I started out misunderstanding this, but the bench is going to be placed at the second smallest corner, so we need to find the middle size side to find the second smallest corner. And the middle size side is going to be off the middle size angle. So we have the largest angle down there at the bottom, the smallest angle at the top. The middle size angle is right there at the intersection of MLK and Hollingsworth Road. So those are the two streets that are going to form the corner for the bench. We could also look at this and see that Valley Road is the second smallest size side, but for this one, they're wanting to know where the bench should go and the intersection of those angles, which is going to be MLK and Hollingsworth. For number 8, it's a little bit of a trick. If we compare those two sides, we've got sort of like a side angle side pattern, except the angle part for the left-hand one is a 90, and the angle part for the right-hand one is a 70. So it kind of stands to reason that the SK side is going to be longer in that triangle than the YU side in the 70-degree triangle, basically because of those two sides being congruent and the side in between, or the angle in between, controlling how big the opposite side is going to be. So SK is the largest side between the two triangles. YU then would probably be the next size side. Now we've also got this triangle inequality theorem. If we look at the side lengths of a triangle, it's a fact that if you add the two side lengths together, any two side lengths added together have to be bigger than the other third remaining side. And also, we kind of end up with a range of values. We can add two numbers together, and whatever the two biggest numbers add up to out of the three in the triangle, the third side has to be a little bit smaller than that. And then we can also do the difference and find the smallest difference between the side lengths that they give us. And the third remaining side between the two that we know has to be a little bit bigger than the difference of those. And we'll get some practice on those. So using the triangle inequality theorem, we've got a 3, a 7, and an 8. 8 and 7 adds up to 15. And 3 is less than 15. If we do this two small ones, 3 and 7, that adds up to 10. And 8 is smaller than the 10. So the different combinations tell us that we can have a triangle with the side lengths in number 1. If we look at number 2, we've got a 9, a 6, and a 2. 9 and 2 adds up to 11, which takes care of the 6. 2 and 6 adds up to 8, but the 9 is longer than 8, so number 2 actually doesn't give us side lengths that can make a triangle. And if we look at number 3 then, looking at the sum and the difference, if we have side lengths given as 4 and 7, 2 of them add up to 11, so the third side has to be less than 11, and the difference of 4 and 7 is 3, so the other side has to be greater than 3. So the range of side lengths are greater than 3 and less than 11.